You're standing on the deck of a massive cruise ship. The ocean stretches endlessly around you, and beneath your feet is something the size of a small city, floating. Then a wave hits. The ship tilts slightly. Glasses clink. The horizon shifts just enough to make your stomach notice. And for a brief moment, a question creeps in. How does this thing not tip over? I mean, look at it. Dozens of decks stacked high above the water, thousands of people moving around, pools, restaurants, theaters, all sitting on top of a narrow base compared to its height. By all logic, it feels like it should be unstable. So why isn't it? And before we get into that, if you enjoy simple explanations that completely change how you see everyday things, make sure to subscribe and leave a like. It helps more than you think. Now, here's the surprising truth. Cruise ships aren't stable because they're heavy. They're stable because of how that weight is arranged. Most people assume that adding weight to something floating makes it more likely to sink or tip. And while that's partially true, it completely misses the deeper idea that actually keeps ships upright. Because stability on water isn't just about weight, it's about something called balance between two invisible points. One is the center of gravity, basically where all the ship's weight is concentrated. The other is something less obvious, the center of buoyancy. That's the point where the upward force of the water is acting. As long as these 2 points are aligned in the right way, the ship stays upright. But here's where it gets interesting. The moment the ship tilts, even slightly, everything changes. The underwater shape of the ship shifts, and when that happens, the center of buoyancy actually moves, not randomly, but in a very specific direction. This creates a kind of invisible lever that pushes the ship back towards its original position. And this is where most people get confused, because it feels like once something starts tipping, it should keep going, like a glass falling off a table. But ships don't behave like that. Instead, they behave more like those inflatable punching toys. You push them, they lean, and then they come right back up. Why? Because of what's happening below the surface. Cruise ships are designed with incredibly heavy components placed as low as possible. Engines, fuel, ballast tanks. All of this weight sits deep in the hull, far below where passengers ever go. That pulls the center of gravity down. At the same time, the wide, hollow structure of the ship displaces a huge amount of water, creating a strong upward buoyant force. So, when a wave tries to tip the ship, the shifted buoyancy and the low center of gravity work together to create a restoring force, not just stopping the tilt, but actively correcting it. And here's what surprises most people. If you took the exact same ship and moved a lot of its weight higher up, say stacking heavy cargo on the top decks, it would become dramatically less stable. Same ship, same ocean, completely different outcome. Because the trick isn't the size of the ship, it's the relationship between where the weight is and how the water pushes back. And that relationship is so precise that even small changes can make a huge difference. Which leads to something even more fascinating. Because cruise ships don't just rely on passive stability, they also use active systems that constantly adjust to the ocean in real time. And once you see how that works, you'll realize these ships aren't just floating, they're constantly fighting the ocean in ways you'd never notice. Because here's the part most people never think about. Even with perfect design, the ocean is unpredictable. Waves don't hit evenly. Wind pushes from the side. Weight shifts as thousands of passengers move, eat, and explore different parts of the ship. So cruise ships don't just rely on physics, they actively manage it. Hidden beneath the waterline are devices called stabilizers, basically underwater wings that extend from the sides of the ship. As the ship begins to roll, these fins adjust their angle in real time, generating lift forces that counteract the motion. It's almost like the ship is flying through the water, constantly correcting itself. And the effect is massive. Without stabilizers, even large ships would feel significantly more unstable, especially in rough seas. With them, the movement becomes slower, smoother, and far less noticeable. But that's only part of the story. Inside the ship, there are also ballast systems, huge tanks that can be filled with water or emptied depending on the situation. If needed, the ship can shift thousands of tons of water from one side to another, subtly adjusting its balance. This is where things get really interesting. Because stability isn't a fixed state, it's something that's constantly being tuned. If strong winds push against one side, the ship can compensate. If uneven weight distribution starts to create a tilt, it can be corrected. All of this happens quietly, automatically, and often without anyone on board realizing it. This is where most people get it wrong. They imagine a cruise ship as a passive object, something that just floats and hopes for the best. But in reality, it's more like a controlled system, constantly responding to forces, always maintaining that delicate balance between gravity and buoyancy. And there's one more subtle detail that makes a huge difference: the shape of the hull itself. Cruise ships aren't just big, they're wide. That width increases stability by spreading out the buoyant force. So when the ship tilts, the shift in buoyancy becomes stronger and more effective at pushing it back upright. Think of it like standing with your feet apart versus balancing on a tightrope. Same body, completely different stability. Now combine that with a low center of gravity, dynamic ballast control, and active stabilizers, and you get something that feels almost impossible. A floating structure the size of a skyscraper that resists flipping, even in conditions that would easily capsize smaller boats. So the next time you see a cruise ship leaning slightly into a wave, remember, it's not on the verge of tipping. It's doing exactly what it was designed to do: leaning, correcting, and staying perfectly in control. Because once you understand the hidden balance between weight, water, and motion, you realize these ships aren't defying physics at all. They're mastering it. And that changes how you see them completely. If this made you look at cruise ships differently, leave a like, share this with someone who's been on one, and subscribe for more explanations like this. Because sometimes the simplest things hide the most misunderstood truths.